Hi students, I'm back as I had promised that I would upload the video for this chapter banking. I suppose you have understood what is the syllabus of ICSE mathematics and you have also understood what is the question pattern. I've thought of starting with a very easy chapter and simple chapter of commercial arithmetic, that is banking. Now, you know that what is the functions of bank. A simple idea you may be knowing that usually we keep money in the bank to get some interest from there. Now there are various types of accounts in the bank. Maybe that can be a savings account, or it can be a loan account, or it can be a fixed deposit account, or it can be a recurring account, and many more. I do not go for so much of details about what are types of account. So the syllabus what is prescribed for ICSE mathematics is you are supposed to study only how to calculate the interest what a bank provides for a recurring deposit account. Now, in order to understand the recurring deposit account, we should understand what is recurring deposit account and how then we can understand how the interest is calculated. So before I begin, once again the reminder is please share this video and subscribe the video if you are new to this video, and so that many more students get benefit from the video and the channel, because now as there is a time of crisis, students are at home unable to go to school. Maybe this video may be some help for them, so that it is not a boredom for them. They are at home and at the same time they gather some knowledge about the chapter. Well, without wasting much of time, let us come back to the subject of the topic, that is recurring deposit. Now, in recurring deposit account, we have a fixed time for the account. Means when we open an account of recurring deposit, at the beginning of opening the account only, we declare that we are going to run the account for maybe 1 year or 2 year or 5 year or whatever it is. So there is a fixed time and there is a fixed amount. Means we give a fixed amount of money every month, so that every month some amount is fixed. We cannot increase or decrease the amount what we are going to pay. And for a given time, suppose it is for 1 year, every month we pay some amount of money, and at the end of the year we accumulate some money, and along with that bank gives some amount of interest. So this is the somewhat idea about recurring deposit account. Let me once again repeat, that is, there is a fixed time we decide before opening the account, and there is a fixed amount which is decided also before opening the account, and that is paid for that particular time at regular intervals, that is 1 month, and at the end of the time period the interest is accumulated and bank pays you your money as well as the interest which has been accumulated, and the money that you have paid and the interest that has been accumulated together gives you the maturity value. These are the terms that we should know. First of all, we understand how the interest is calculated, then we shall understand how the maturity value is calculated. So before understanding the calculation of interest, we should know this formula, that is, suppose we have to add the sum of first n natural numbers. The formula is given by n into n plus 1 by 2. This is the formula for adding the first n natural numbers. Now, let us come to the interest part. Let us take an example to derive the formula for recurring deposit account. Suppose a person decides to pay rupees, say 500 per month for say 1 year. Every month he is paying 500 rupees for 1 year. That means first month he pays 500 rupees, that is kept for whole year. Then again 500 rupees kept for the next 11 months. Then 500 rupees for the next 10 months, and so on. That means 500 rupees is paid for 12 months. First installment. Second installment. Again rupees 500, which is kept in the bank for 11 months. Because he has not paid 1000 rupees at the beginning. He has paid only 500 rupees, and that money will be there with the bank only for the coming 11 months. Similarly, the third installment which he pays for the third month, that is also for 10 months. And so on till he pays the last installment, that is 12th installment, that is rupees 500 for 1 month. So let us understand what is the equivalent principle. The term is equivalent principle, means how much money actually he is keeping in the bank. So bank had not kept 500 into 12. That means you may be thinking 500 I am keeping every month for 12 months. So 500 into 12, that means 6,000 rupees I am keeping for 12 months. No, you are keeping first 500 rupees for 12 months. Second month when you are paying 500 rupees, that you are keeping only for 11 months. Third installment when you are paying, that you are keeping for the 10 months, and so on. So equivalent principle is equal to rupees 500 into 12 plus 500 into 11, and so on up to 500 into 1. So if I take 500 common, then 12 plus 11 plus 10 up to 1. So this is, if I see from that side, it is the sum of first 12 natural numbers. So let us come to this formula back, for which I had initially given you the formula, that is sum of first 10 natural numbers is n into n plus 1 by 2. So here it will be rupees 500 into 12 into 12 plus 1, that is 13 by 2. So this becomes 6. So 500 into 6 into 13. Whatever it is, we don't go for so much of calculation. So this much amount of money is paid or is kept with the bank for the whole year. This is the equivalent principle. Now let me tell you that in bank, for this recurring deposit account, the interest is calculated with the formula of simple interest. That is, you know, SI is P into R into T by 100. So interest will be, this is the equivalent principle, whatever it is, into R into T. T is n into n plus 1 by 2. So whatever is P into R into n plus 1 by 2 into 100. And since it is in terms of month and the rate is in terms of per annum. You will be given rate in terms of per annum. So you are supposed to divide the time by 12. Here T is n into n plus 1 by 2 months. So into 12 will give you the, by 12 will give you the time in terms of years, or time is n into n plus 1 by 24 years. So the formula is P into n plus 1 into R by 2400. Okay, so what is n here? N is the number of installments I am going to pay. R is what? Rate of interest that will be given by the bank, and P is the per month installment. Per month, how much you are paying. So this is the formula for interest of a recurring deposit account. Now we shall understand the formula with the help of a problem.
Sweta deposits rupees 350 per month in a recurring deposit account for 1 year at the rate of 8% per annum. Find the amount she will receive at the time of maturity.
So in this question, we are supposed to find out the maturity value for a person who is depositing rupees 350 for 12 months, because 1 year. So he has to pay for 12 installments, and the rate of interest is 8%. Now I is equal to P into n plus 1 into R by 2 into 12 into 100. So let us put the values. That is 350 into 12 into 13, because 12 plus 1 13, into 8 by 2400. So here it is 300. So 5 sevens are 560. 2. So it is rupees 14 into 13. So that is rupees 182. Now we are supposed to find out the maturity value. Maturity value, that is the maturity value means actually the amount that you have paid to the bank along with the interest. So that is how much amount you have paid. You have paid for n installments this amount every month, that is P, plus the interest. So that is 350 into 12. So maturity value is n into P plus interest, and n is 350 into 12 because P is 350 and n is 12 installments. Interest is 182 we have calculated. So this, after calculation, it comes to rupees 4,382. So the person had paid 350 into 12, that is 4,200, and he gets 182 as his.
Mr. Gupta opened a recurring deposit account in a bank. He deposited rupees 2,500 per month for 2 years. At the time of maturity, he got rupees 67,500. Find the interest earned and the rate of interest.
Well, in this question, principal or the per month installment, which is 2,500, here rate of interest is not given, that we are supposed to calculate, and number of installments is 24 because it is for 2 years. So 2 into 12, that is 24 installments we are supposed to pay. Now what we are supposed to calculate is first of all, what is the interest he is getting, and secondly, what will be the rate of interest for this particular sum. Now, in order to calculate the interest, we are supposed to know what is the amount he has paid. Amount paid, that is rupees 2500 into 24, that comes to rupees 60,000. So interest, so first part was interest, that will be rupees 67,500 minus rupees 60,000, that is rupees 7,500. And what is the rate of interest? Rate of interest will be P into, let us put in the formula, N into N plus 1 into R by 2400, which will be equal to 7,500, or 2,500 into 24 into 25 into R by 2400, that is 7,500. So after calculation, we get R is equal to 7,500 divided by 625, that is 12. 12% will be the rate of interest. Let us see the final question. Then I suppose
Mr. R.K. Nair gets rupees 6,455 at the end of 1 year at the rate of 14% per annum in a recurring deposit account. Find the monthly installment.
in this question we have the maturity value as rupees 6,455, which is the time period is 1 year, that is 12 installments, and rate of interest is 14%. What we are supposed to calculate is the per month, what is the installment paid in order to receive this much amount of maturity value. So this is the formula you know very well. So let us put the values. 12p plus 12 into 13p into 14 by 2400, that is 6455. On simplifying, and 7, so this is 1200p plus 91p is equal to 645500. So that is 1291p, that is 645500, or p is 645500 by 1291. On calculation, we see that it comes to rupees 500. So we have seen, so this is the per month installment that the person has to pay to get the maturity value. So we have seen 3 questions, 3 examples. I suppose that will cover the whole chapter, where we had to calculate the interest in the first question, then we had to calculate the rate of interest, and here we had to calculate the per month installment. So these are the main types of question, and we may have one more question, that is where we have to calculate the number of installments. That can be also calculated in the same way, just putting the other values, you can get the value of n. I suppose that you have understood the concept very well. Please go through the chapter once again, the examples and the concept, and try to do the sums of the given exercise. Any doubts, any clarifications you have, please put it in the comment box. I shall try to answer. Thank you. See you. Stay safe.